Happy morning, dear students and friends. In this session, we are going to discuss about the dynamic Huffman coding. So the dynamic Huffman coding is basically used in the online data transfer. You all are familiar with the static Huffman coding. In the static Huffman coding, both the transmitter and the receiver knows the complete code word set before the data transmission is being carried out. Whereas in the dynamic Huffman coding, the transmitter and receiver builds the tree and the code as the symbols are being transmitted and received without knowing the complete knowledge about the characters. The complete knowledge refers how many number of characters are there and what is the frequency of occurrence of each and every character. It builds up the knowledge about the characters that are present in the text and their relative frequency of occurrence dynamically as the characters are being transmitted and received. And it creates an optimum set of code words and that varies from one transfer to another. It is conventionally used in the transmission of text when the transmission is varied from one transfer to another. This can be explained with an example. Assume that we want to transmit the data or the information to be transmitted as Q. As you all are familiar, this Huffman tree will consist of three types of nodes. They are root node, leaf node, and branch node. Dynamic Huffman tree normally starts with the root node and an empty leaf node. This is our root node, and it starts with an empty leaf node. This empty leaf node is designated as E0. Okay. Now, what are the characters? Each and every time the character is going to be transmitted one by one. This is a character, and for each character you will construct a tree, and by that time what is an information transmitted to the receiver. See, in the dynamic Huffman coding, both the transmitter and the receiver parallelly construct the tree. What is our first character in the text? It is Q. Therefore, the data to be transmitted is Q now. Okay. So when the first character to be transmitted, what happens to the tree? This character Q is assigned to one right branch of the tree. Okay. Now, this left branch is assigned with an empty leaf node, and the right branch is assigned with the character Q, and it is the first time of occurrence. It is referred as Q1. Always the left branch is referred with the label 0, and the right branch is assigned with the label 1. And this is our root node. By that time, what is being transmitted to the receiver? This is the first character of the text. Therefore, the Q is transmitted in an ASCII form. The Q is transmitted in ASCII form. Okay, right. Now, what is the next character to be transmitted? The U is the next character to be transmitted. Now, what the encoder will do, it converts this empty leaf node as a branch node. It converts the empty leaf node as a branch node. Therefore, this is an already existing branches nodes, and this empty leaf node has been modified as branch node. Okay. So node. Now this can be assigned empty leaf node. And what is the character received or to be transmitted? It is U, and it is also the first time of occurrence, therefore U1. And this is going to be my leaf node, which is designated with the character Q1. Okay, and I will say I'll know the left branch is 0, right branch is 1, left branch is 0, right branch is 1, and we should assign the weight for each node. What is the weight for this node? The probability of occurrence of the empty leaf node is 0 and this is 1. Therefore, the summation of these weights, therefore this is going to be 1. What is the weight of our root node? It is going to be 2. It is going to be 2. And then, what is the information being transmitted to the receiver? This is the first time. So, the position of the empty leaf node of the previous stage. What is the position of the empty leaf node of the previous stage? It is 0. It is 0. And what is transmitted? This U is transmitted in ASCII form. Right? Okay. Now, what is our next character to be transmitted? Our next character to be transmitted is E. So what will happen? Again, the tree is going to be, this empty leaf node is going to be modified, or it's going to be a branch node. It is going to be a branch node. So I'm going to draw. It is there. This is my existing tree. Now this branch node is modified as, sorry, empty leaf node is modified as a branch node. So now what is the character you are going to assign here? You are going to assign E, and this is the first time, and this is U, it is the first time, and this Q, and that is also occurring only once. Okay, right. Now what is this one? It is going to be my empty leaf node. Empty leaf node, right? So what is the weightage of this node? 0 plus 1, 1, and this is 1 plus 1, 2, and this is 2 plus 1, 3. What does it indicate? Totally 3 characters are labeled or placed in the tree. What is the information being transmitted to the receiver? Because it is a new character, the position of the empty leaf node of the previous stage. What is the position of empty leaf node in the previous stage? 0 and 0. Therefore, it is transmitted as 0 and 0. And along with that, this E is transmitted in ASCII form. Thereby, the receiver identifies that this is the first time the particular character is arriving. Now, after this, before moving to this, otherwise, before moving to the next stage, you should check whether the tree is optimum or not. How will you find out whether it is optimum or not? By writing the weight list. How will you write the weight list? By reading the tree from left to right and from bottom to top. From left to right and from bottom to top. Now we'll write the weight list. What is the left to right? Therefore, E0. And what is our next character? E1. And then 1. Because E0, E1, 1. U1, 2, Q1, and 3. You check whether it is following an ascending order. Is it following an ascending order? Definitely not, because this 2 is here, and see, whenever the character is concerned, you have to see the probability of occurrence. For the other nodes, for the branch nodes, only the number you have to consider. Here it is Q1 and it is 2. Therefore, these two have to be interchanged. Therefore, what is our updated weight list? Our updated weight list is going to be E0, E1, 1, U1, Q1 and 2 we are swapping. So 2 and 3. Okay. Now we are going to draw an updated tree. Now the tree is drawn. While drawing the updated tree, you have to derive that you have to draw a tree. You have to draw the tree from top to bottom and from right to left. Top to bottom and from right to left. This is our updated weight list. Okay. So I'm referring. This is my updated weight list, and this is now I'm going to draw an updated tree. Using the updated weight list, I'm going to draw a tree. Okay. Updated tree. So how will you draw an updated tree? Read the list from right to left, therefore, and from top to bottom. So here it is assigned 3, and here right to left 2, and here it is going to be Q1. Okay, and this Q1 is assigned to a node, so it becomes a leaf node. Now this branch node can be, this 2 can be a branch node, and after Q1 what you have, this is going to be my U1, and this is going to be 1. Now this U1 is assigned to a node, therefore this is going to be a leaf node. Therefore the next thing, I am going to convert this thing as my branch node. Do you understand? So after 1, this is my E1, and this is going to be my empty leaf node. Empty leaf node. Okay, leaf node. Again you check, this is 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3. So it is following an order. Now I am going to receive the next character. What is our next character? Our next character is QUE is over U. Whether it is an existing character or a new character, it is an existing character. By that time, what you have to do, you will not extend the tree. You will increase the probability of occurrence of that character. So you see that in the tree, where you have the character U, so here you have a character U. Therefore, what is the probability of this U1 has to be modified as U2. Okay, and before that, here I will specify the labels for the right branch, left branch. Left branch is 0, right branch is 1, left branch is 0, 0, right branch is 1. Okay, right. Now for this character, what is an information being transmitted to the receiver? The information to be transmitted is, as it is an existing character. Listen carefully. As it is an existing character, only the position of that character in the previous stage. So what the same operation is done at the receiver also. So what is the position of this character in the previous stage? It is 1, 1. So what is being transmitted to the receiver? Only 1, 1 is transmitted. Okay, what happens to the tree? You have to draw the tree as such. Draw the tree. Draw the tree as such, and only thing, you have to change our probability of occurrence of this character is U2. And what about this one? This is going to be my empty leaf node, and this is going to be my character E1. So what is the weight of this node? It is 1. And what is the weight of this node? It is 3. And what is the character assigned at this stage? It is Q1. So what is the total weight? 4. Totally, the transmitter has transmitted 4 characters. That is specified here. Now, 1 is transmitted. So how many bits we are saving? Instead of transmitting 7 bits for the transmission of U in ASCII, here we are transmitting only 1. Right? And before proceeding to the next stage, you have to write the optimal weight list. You have to check whether it is an optimal weight or not. So E0, E1, 1, U2, Q1, 3, and 4. Check whether it is an optimal condition, whether it satisfies the optimal condition. No, because the U2 and Q1, these two have to be swapped. So what is our updated weight list? Updated weight list is not V1, 1, 1, Q1, U2, 3, and 4. This is my updated weight list. For this updated weight list, I am going to draw the tree. So how will you draw? I will draw it here. So assume my tree. So it is going to be, it is 4, it is 4, it is 3, here, U2, and then this 3 is made to 2 branches. After U2, this is going to be Q1, this is going to be 1. So this becomes the leaf node and this one is modified as a branch node. Therefore, it is E0 and this is going to be E1. Okay. Now E0, 1, 1, 1 plus 1, 2. Actually, it is specified here as 3. Therefore, you have to modify this into 2. You cut it and write. Okay, so 2. It specifies this node as having the weight 2. Okay, so I am writing the actual weight is 2 here. This 3 is an unwanted, this modified weight. Now, what is our next character? So, it is an optimal tree. What is our next character? It is E. So, it is an existing character? Yes. So, when it is an existing character, what has to be transmitted? The position of that character in the previous stage. So, what you have to do here, left branch is 0, right branch is 1, left branch is 0, right branch is 1, left branch is 0, right branch is 1. Okay. Therefore, what is the position of this character E in the previous stage? You read from the tree. So 1, 0, and 1. Therefore, what is the information transmitted to the receiver? 1, 0, 1. So how many bits are saved? 5 bits. Okay. Alright. Now what you draw the same tree and only this position you have to modify. So it is E0, E1, not E1, E2. And therefore it is going to be 2. And this is Q1. And this is 2 plus 1, 3. and this is U2. U2. Therefore, this weight is 5. Okay. So this is a tree created. Now you check whether it is an optimum or not. So create a wait list. How will you write the wait list? E0, E2, 2, Q1, U2. Always remember, while writing the wait list, you should read the tree from left to right and from bottom to top. To check whether it is satisfying the condition. No. Here this is Q1. This probability of occurrence is 1, whereas here it is 2. Therefore, this E2 and Q1 I can swap. Therefore, what is our updated wait list? It is going to be, my updated wait list is E0, E2, not E2, Q1. In some of the problems, you may have to do 2 or 3 swappings. That is allowed. So E0, Q1, 2, E2, U2, 3 and 5. Okay, for this, you are going to draw the tree, updated tree. How will you draw an updated tree? Updated tree will be drawn by reading the wait list from right to left and construct the tree from top to bottom and from right to left. Therefore, what is the wait list? This one, it is going to be 5 and this is 3. This is U2. Now this is a leaf node. This 3 is a branch node and it can be divided into 2 branches. After U2, I have E2 here. Therefore, E2, E2, 2, 2, and this is a leaf node. Therefore, this node can be a branch node. After 2, 5, 3, U2, E2, 2, and this is going to be Q1, and this is going to be E0. Again, you check the list, weight of the each branch nodes. 0 plus 1, it is 2 here. Therefore, you have to modify that as 1. And then 2 plus 1, 3, 3 plus 2, 5. Total in the string, you have 5 characters. So this is the thing. So what are the, and you specify what is our left branch and the right branch. Left branch is 0 and the right branch is 1. So what are the things you should remember? Always the tree starts with an empty leaf node and one leaf node. Leaf node cannot be a branch node. Normally the characters are, once the characters are assigned to that node is referred as a leaf node. And optimum wait list. So to construct the optimum wait list, the tree is read from top to bottom. By tracing the tree from left to right and from bottom to top. And it has to follow an ascending order. If the condition is not satisfied, you can swap the weights, and according to that updated weight list, you should create an updated tree. While constructing the tree, the weight list is read from right to left, and the tree is constructed from root node and from right to left. The process is repeated until you transmit all the characters. Hoping that you enjoyed the session. If you have any doubts, you can post your questions to my mail ID. My mail ID is Dr. Avudaiammal@gmail.com. Thank you.